DHCP, it's very easy for us to understand, right? Who wants a dynamic IP address? I will apply for you. And in some special scenario, maybe some static IP address and dynamic IP address are same, then we can use an IP source score to solve the problem. And then maybe in the network, there's some illegal interface, illegal DHCP server. Of course, you have to know maybe some interface will become access the illegal DHCP server. So about this interface, you can make to become untrust. And which interface directly to connect with your legal DHCP server, you can make them to become trust. So these are typical. It's very easy about the DHCP. And the next part is about the VLAN. VLAN also is very important, right? I think maybe you don't know what's some key point of the VLAN, but you already configure the VLAN. Maybe in the wireless part, in the wired part, in the router. Router, maybe you don't give the VLAN configuration. On the EG, on the switch, so many devices, so many scenarios, you will use a VLAN. So why we use a VLAN? What is a VLAN? What's the problem we can solve if we deploy the VLAN? So first, let's see why we need the VLAN. Like this topology, it's a little more complex than the first one when we talk about the DHCP, right? In our scenario, maybe we have different departments located in different flow, and different flow, maybe we have the access switch and connect with the distributor switch. Then there is a problem. If the IT department send out the broadcast packet, the destination MAC address is F. When the switch receives, the switch will do the flood, right? What means the flood? I will send out the packets to all the interface except the receiving interface. Then this switch will flood again. Finally, all the terminals in the network will receive the broadcast packets. Pay attention, if in your network there is a loop, or maybe you have so many broadcast packets, all the link will forward the packet, but finally this packet will be discarded, right? For example, maybe this is a DHCP client. I send out a request to find the DHCP server. Finally, only the server give us the reply. It's enough. All the other will discuss this broadcast packet. So there is a waste resources of the link of the devices to deal with this broadcast packet. So how to limit the broadcast domain? For example, maybe this broadcast packet, I only hope the third computer can receive, the other cannot. How to solve this problem? One solution, we can deploy the router on our network. Because about the router, by default, we will not forward the broadcast packets. And another one, we would use a VLAN. If we add the packets, some tag information to ask the switch, this packet, you only to forward in the same tag. If not same, we will discard. So this is a function of the VLAN. And then let's see, if we add some tag on the packets, this packet we call is AO2.1Q. Maybe in your computer, you use a command to encapsulate with AO2.1Q. This means you add the configuration of the VLAN. So what's the information of the tag? For example, by default, all the packets will only have the destination MAC address, the source MAC address, and the type or length information. Then the upper layer is a data frame, maybe it's IP information, something else. And we have some FCS to do track. If we add the tag will located on the layer 2 header. And what's the information here? We have several paths. The first one is a TP ID. This TP ID value is fixed. The value is A100. And the next part is a TCI. And about TCI, we have 3 parts. The first one, VLAN ID. We have 12 bits long, and this one is used to indicate VLAN. So the range is from 0 to 4095. 0 to 4095. And the available one is 1 to 4094. So this is available one, and used to uniquely identify a VLAN. So in your scenario, maybe you create a VLAN, right? You can create 100, 1000, 2000, but you cannot create VLAN 5000. This is a limitation of the VLAN ID. Okay. And the second one is a priority. It has 3 bits long. Indicates the priority used for the QoS. Maybe in your network, the resources is not enough. So we hope we can force some traffic as soon as possible or at first, like some voice date or some maybe date traffic, something like this. So we have to some information to indicate different priority. We also can use this part to indicate different resources. And the last one is CFI, only 1 bit long, indicates a different type of the Ethernet or FDDI or token array. So about this part, we have to focus on the VLAN ID. About the length long, maybe I say why you only can create the VLAN 200, you cannot create 20,000, something like this. So this is a limitation. And then let's see if the switch for the traffic by default, I only receive the packets and according to the destination MAC address, then to check the MAC address table to finally to forward the traffic to the correct interface, right? But if you add the VLAN, the switch for the traffic not only consider about the MAC address, we also have to consider about the VLAN. If the PC send out the standard Ethernet frame, that means without VLAN information, and about the switch, this interface we assign to become VLAN 10, the interface 2 is become VLAN 20, the 3 is VLAN 10. Finally, your MAC address table also will be different. Not only have the MAC address, we also have the interface, also have the VLAN. So if the PCA sends the packet to the switch, when the switch receives, I will add the VLAN 10. Finally, I will forward the traffic to the destination. I will check what's the destination MAC address. I also will consider that your VLAN is VLAN 10. I only can send the packets to VLAN 10, like the interface 3 or maybe interface N. So the result, this packet cannot be forwarded on this interface. About the switch, if the switch only can belong 1 VLAN, and when I receive the standard Ethernet frame, I will add the VLAN information. When I send the packets out, I will delete the VLAN. Of course, the VLAN number should be same. This interface we call it access interface. And about the access interface, usually is used to connect with the terminal. So this is the first one about access. It's very easy to understand. About this topology, it's easy for you, right? During all the terminal to connect with the switch. But this is a typical topology in our real network. For example, PC1 and PC3 in the same department, maybe it's IT department, they located in different switch, but they belong to the same VLAN. If PC2 and PC4 in the finance department and also located in different VLAN. Within the same VLAN, we can directly to communicate with each other, but different VLAN cannot. So in this scenario, if we only have access switch, access interface, PC1 can communicate with PC3 and PC2 can communicate with PC4 or not. If we only have access, the same VLAN can communicate with each other or not. Who can give me the answer? If we only have access switch, access interface, can they communicate with each other? Actually, the answer should be not, right? With different VLAN, no. With the same VLAN, can they communicate with each other or not? If we only have access interface. Yes? Yes? Okay, I see. So many answer is yes, right? Let's see the process. For example, if now the switch 1 and the switch 2, let's have a pen for you. PC1, this is the access switch belong to VLAN 10, right? This is an interface belong to VLAN 20. Okay, I have a question for you. What's the VLAN of this interface? If our type is access, what's the VLAN should be? 10 or 20? If we configure the interface to become access interface only can be at one VLAN, right? So what's the VLAN should be? If we can do the configuration, 1. Yes. If we can change the VLAN tag, for example, now we change the first interface, the VLAN to become 10, the second to become 20, right? If now this interface also is an access interface, because access interface only can belong to one VLAN. So maybe now we create the VLAN to become 10. The same configuration of this side. The VLAN is 10, the VLAN is 10, and this VLAN is 20. Okay, now let's see the process. PC1 and PC3 can communicate with each other or not. PC1 sends the packets out without the VLAN tag, right? And the switch 1 receive, I will add the VLAN tag. The VLAN is VLAN 10. If we add the VLAN 10, the packets cannot be sent to interface 2, right? Because this VLAN is VLAN 20. Can we send out these packets out? Yes. And before we send the packets out, we will delete the VLAN. This is the principle of access interface. When I receive untagged packets, I will add the VLAN tag. When I send the packets out, the VLAN tag is saved, I will delete the VLAN. So this is the principle of the access. So in this process, in this cable, we will send out packets without any tag, right? And then when this interface receives the packet, I will add the VLAN 10 again. So finally, this packet can be sent out of the interface 1 because this interface also belongs to VLAN 10. So in this scenario, in this configuration, PC1 and PC3 can communicate with each other successfully. But in this scenario, PC2 and PC4 can communicate with each other or not? Yes or not? 2 and 3. If in this configuration, no, right? Because let's see the process. PC2 send out the packets to the switch 1. Switch 1 will add the configuration of add the VLAN is VLAN 20. Pay attention. If we have the VLAN 20, we cannot send the packets out, right? Cannot, because our VLAN tag is different. Can we send out the packets on this interface or not? Of course not, right? Because this VLAN tag is 10, but we have the VLAN 20. So in this topology, if we only have the interface is access, they can communicate with each other successfully. Actually, the answer is no. So that's why on this topology, we need a new interface type. This one we call is trunk, right? We call it trunk. Trunk means we can allow multiple VLAN to pass through. And this frame is usually sent out with the tag together. And then this interface usually will be used between the switch. So pay attention about the trunk interface. If this interface is a trunk, for example, this is a trunk configuration, and we allow the VLAN 10 and 20, and PC1 send out the packets to switch 1. Switch 1 will add the VLAN 10, and this packet cannot be sent to PC2 because this interface only can forward about VLAN 20. But this interface can be sent out of the interface 20 because this is a trunk interface, and we allow the traffic with the tag out. So we will add the VLAN 10, and then send to the switch 2. When switch 2 receives this packet, I will send the packet to PC3 again because we have the same VLAN. The same process of the VLAN 20, I send to the switch 1. The switch 1 will add the VLAN 20. This packet also can be sent out of the interface 20 with the VLAN 20 tag to the switch 2, finally sent to the PC4. So this is a function of the trunk. Of course, there is a special VLAN of the trunk. We call it the default VLAN. The default VLAN, also some places we call it native VLAN. The native VLAN means when the trunk sends the packets out, I will track the VLAN information compared with my native VLAN. If this packet's native VLAN is same with the packet, I will delete the VLAN and then send the packets out. So this is a special one of the native. And if we don't add the configuration, the native VLAN is VLAN 1. Okay, is a VLAN 1. So this is a function of the trunk. Yes. And how to give the configuration? Pay attention. If you want to make the interface to become access and then add the VLAN is VLAN 10, or maybe you want to make the interface to become trunk to allow some VLAN paths, you have to add the configuration. By default, we only can deal with the VLAN 1. VLAN 1 is the default VLAN, is special one. So the first we have to create the VLAN. In the switch, only the VLAN 1 located on the switch. If you want to use the other VLAN like 20, like 1000, you have to create. And then you have to configure the access interface, configure the trunk interface, then we can check the result. So this is a step. Let's see how to give the configuration of the creation VLAN. The first one, create VLAN. The command is here, VLAN, and then is a VLAN ID. And you can give the name of the VLAN. Of course, this is an optional configuration. If you don't add this command, the VLAN also can work. And here is an example. VLAN 10 and the name is IT. VLAN 20, the name is finance. Then we have to configure the interface VLAN of the access. We have to enter the interface and change the mode to become access. And then add the special VLAN. This VLAN we also can say is the native VLAN of the access. Switch port VLAN and what's the VLAN number. This is the command. You can enter multiple interface to make all of the interface to become access, and the VLAN is VLAN 10. And of course, you can enter in the only one interface to make the access VLAN to become 20. By default, some switch, the default interface type is access. So you only add the native VLAN of the interface is enough. But some other vendor or some different series of switch, the type maybe is trunk, you have to change to become access at first, and then you give the native VLAN. About the trunk, you also have to enter the interface to switch the mode to become trunk, and pay attention, you have to add the control behavior. For example, maybe relay, remove, or maybe allow some VLAN alone, something like this. About the trunk, you only allow the VLAN in your interface, then the trunk interface can forward the traffic with the tag. Otherwise, also cannot. So there is a typical command. Enter the interface and change the mode to become trunk. And of course, maybe this interface usually is used to connect with switch. And then enter the special interface to allow the VLAN remove from 1 to 4094. That means this command is used to let the interface cannot forward any VLAN. And then you can add your service VLAN, for example, for the user VLAN 10 and VLAN 20. So the interface 2 only allow VLAN 10 and VLAN 20 pass through. If you get some VLAN 30 packets, the packets cannot be forwarded of the interface 2. Pay attention. And here, if we don't change the native VLAN, by default, the native VLAN is VLAN 1. Pay attention, the native VLAN is VLAN 1. So if you receive some packets with the VLAN 1, when I send out of the interface 2, I will delete the VLAN. So this is a function of the trunk. And then check the VLAN status and the port status. Some command. If you don't use this VLAN, you can delete the VLAN. The command is no VLAN and add the VLAN ID. Pay attention, you cannot delete VLAN 1. Or the other VLAN you can delete. And we can track some VLAN information like show VLAN. Now in this switch, we create the VLAN 1, VLAN 10, and VLAN 20. And which interface can forward the VLAN packets? About VLAN 1, we have many interfaces because by default, every interface can forward VLAN 1. If you create, for example, about the interface 2 to become access and the VLAN is 10, this interface will be located on the VLAN 10. So this is the result. You can use a command to check. And here is a summary of the VLAN. So what's the purpose of the VLAN? We have to know. We want to control the broadcast domain, and then we can improve the network bandwidth utilization and reduce the resources waste. So that's why we use the VLAN. Of course, in your network, we don't have so many terminals, or maybe we already have the router. You can only use one VLAN, it's okay. And to enhance the security, we can create the user group and restrict access between different user groups. So this is a purpose. And this one is very important for us. We talk about two types of the switch, right? One is access, one is trunk. And how to deal with the packets? We divide the process to become receive the message and send out the message. The process is different. When we receive the packets, maybe receive the packets from terminal, maybe from the switch. Different interface, we will have different process. If we receive the packets without tag, access interface or trunk interface, we will directly add the native VLAN to the packets. If we receive the packets carry the tag information about the access, we will compare the packet VLAN and of my native VLAN. If the VLAN is same, I will receive. Then maybe I will do the forward. And if the VLAN ID is different, we will directly to discard. But about the trunk, when we receive the packets and have the VLAN information, we also will compare with our native VLAN. And about the native VLAN is same, we will receive. If the VLAN ID is different, we will track the VLAN on our permission list. If in our permission list, we will receive. If not, we will discard the packets. So pay attention about this part. If we send the packets out about the access, we will directly to remove the tag and send the packets. Of course, the VLAN tag and the interface native VLAN should be same. About the trunk, We also will compare with the native VLAN and the packet VLAN. If same, we will remove the tags and send out the packets. If not, I will keep the tag and send the packets out. So this is a process of the packets. The question is, anyone in E, what's this? I think you found your friends. Okay, here is a summary of the VLAN. So, any question about this part of the VLAN? Do you have any question? No more question? So I think maybe you are very clear about the VLAN, right? So how about reserved VLAN? Yes, reserved VLAN is the VLAN 0 and the VLAN 4095. That's why we say the range is from 0 to 4095, but the available one is 1 to 4094. The reserved VLAN cannot be used. Okay, if you don't have the problem, maybe I will have a question for you. So now I think everyone already know what means VLAN, right? And what's the principle of the VLAN. So here is a question. There are two switch. Between two switch, the interface type is trunk, but the native VLAN is different. The left one native VLAN is 30, the right one native VLAN is 20. And then the switch one connect with 3 PC. All of them, the interface type is access interface, but the VLAN ID is different, 10, 20, 30. The right one also is access interface, 10 and 20. Finally, the question is, which of the following hosts can communicate with each other successfully? A, B, C, and D. Please show me the correct answer. Boy, ready? Communicate with each other means the left sends the packets to right, and the right can give a reply successfully. That means we can communicate with each other. B, C. This is a multi-choice question. Nothing? Ready? E? Maybe I think you'll see another picture, not on my part really. Boy. A and B. No more answer? No answer, right? A and B. You also have to consider when PC5 sends the packets out, which site can receive. If you choose all, I think you maybe can get the correct answer, right? Okay, so maybe our time is very important. So I will explain for you now. First, pay attention. This topology only used for you to understand the principle, because in the real network, generally in the same link, different switch, we will use the same native VLAN. Okay, we will use the same native VLAN. So let's see the process. The first one, If PC1 sends the packet to switch 1, right? We will add the VLAN. The VLAN is VLAN 10. So the packet cannot be sent to 2 and cannot be out to 3. Only can send out of the trunk interface. I will add the pen. PC1 sent to switch 1. We will add the VLAN 10. And finally, only this interface can send out the packets, right? Carry the VLAN 10 or delete. Carry or delete. I will remove the tag or not. We will ready. We will carry or delete. Depends on this VLAN and your native VLAN is same or not, right? If they are same, I will delete. If not, I will carry the packets out. Okay, so this is a summary of this table, right? When we send out the packets, this is part about send out. If the VLAN ID is same, I will remove. If not, I will keep the VLAN tag. Yes. So this package will carry the VLAN 10. About this interface, when we receive the VLAN 10 package, I will add into the switch. Of course, about the permission list, we allow the VLAN 10, 20, and 30, right? Because this package carries the VLAN 10, so the package finally only can be sent out of the interface 1. Send out. When I send out, can we delete the 10 or carry the 10? When we send to PC4, we will delete the VLAN, right? About the access interface, when I send out the package, I will remove the VLAN information because our terminal cannot recognize the VLAN information. So PC1 sends the package to PC4, it's successfully. If PC4 give a reply successfully too, right? The same process. When we send out to the switch 2, I will add the VLAN 10. And then VLAN 10 only can be sent out of the trunk interface, carries the VLAN 10 information because the native VLAN is 20. And to the switch 1. About the switch 1, only the first interface can recognize this packet because the VLAN is 10. So finally, the packet also can be sent out. So this is a process. So the answer A is correct. A and PC1 and PC4 can communicate with each other. And then let's see the next one. If the PC2 sends out the packet, pay attention. When we send out the packet to switch 1, we will add the VLAN is VLAN 20. About this packet cannot be sent of interface 1, also cannot be sent of interface 3, but we can send out of the trunk interface. About the trunk interface, we will carry the VLAN 20, right? Because the number is different. So when switch 2 receives the packet and carries the VLAN, I will add into the switch and finally send to the switch 2 successfully because this is access and the VLAN is 20. So 2 to 5. It's okay. Let's see the reply about the PC5. If PC5 sends the packet to switch 2, we will add the VLAN is 20, right? Okay. Then the packets will send out of the switch 2. Okay, the key point is switch 2 will delete or not. Switch 2 will delete the VLAN tag or carry the VLAN. Yes, the correct answer is delete. So when the switch 2 sends out the packet without the VLAN tag, when switch 1 receives, I will add the tag, right? Because we don't see the VLAN information. So which VLAN will be added? VLAN 30. This is a native VLAN. Yes. And finally, because this packet has the VLAN 30 information, so the packets will be sent out of PC3. Right? So About the PC5, if we send out to PC2, PC2 cannot receive. But if PC5 send to PC3, it's correct. So the answer is, if PC3 sends the packet to PC5, PC3 can receive or not? The correct answer? If PC3 send to switch 1, what's the VLAN tag? Should be 30, right? And then the packets will be sent out of the trunk. Then the trunk will delete the VLAN, right? Because this number is same. So when switch 1 send out without the tag information, switch 2 receive. Switch 2 will add the VLAN, right? Add the VLAN 30. And then when switch 2 receive this packet and we add the VLAN is VLAN 20, sorry, is VLAN 20. Finally, the packet can be sent out of the PC5 because this interface also belongs to PC5. That means if PC3 send out to the message of PC5, it also can successfully. So finally, the correct answer is 1 and 4, and another one is 3 and 5. Okay. So the correct answer should be A and C. So do you know the correct answer? Can you get it? It's okay for you to understand this process? This is the main process of this part, the summary. How to deal with the message with the tag or without the tag. It's clear for you, right? So the correct answer is A and C. It's easy for you to understand, I think. Now you can know the detail of the VLAN. About the answer C. Okay, wait a moment. Yes, so that's why I say I only give the topology for you to understand the principle. Because in the real network, the net VLAN maybe will be same, but depends on different vendor. For example, like some vendor switch, if the net VLAN is different, they cannot work about this two interface. But about some vendor switch, they are only a warning for you. The other side, the net VLAN is different with me, but we still can communicate with each other. But about this topology, only used for you to understand better of the net VLAN function and the access and the trunk interface. So there will be a task, yes. Okay, the option C, right? Why PC3 and PC5 can communicate with each other? First, we have to know if PC2 sends a message to PC5, PC5 can receive. If PC3 can send a message to 5, PC3 also can, PC5 also can receive. Both of them can receive the packet successfully. But if PC5 give a reply, only PC3 can receive. PC2 cannot. So that's why we say the communicate with each other. If I send to you, you can give a reply to me. That means the communication is successfully. Okay. So why PC5 sends a message only PC3 can receive, although they have different VLAN, right? PC5 sends a message to PC2. We will add the VLAN is 20. When the switch sends out the packets out, I will compare our native VLAN with the tag VLAN together. we will find the VLAN is same. If the VLAN is same, we will delete the VLAN. So in the link, we will send out the packets without any tag information. When the trunk interface receives the packets without the VLAN information, I will add the net VLAN. The net VLAN is 30. So now I have to force the packets with the VLAN 30. Only this interface can be sent out. So that's why we say the option C is correct, because when PC2 send out to PC5, cannot get the reply from the PC5. So it's easy for you to understand. Okay. So this is a VLAN, right?